Hi everyone. Let's discuss on the topic how can you ensure superiority over AI. So in this world where AI has been very aggressively progressing, I would say it's almost exponentially getting better day by day. How can we ensure that we as humans are able to remain superior over AI? You must be hearing that AI is going to take over your jobs. Some of the jobs are going to get redundant over time. But it's true that AI is making inroads into a lot of tasks like translations, data extractions, categorizations, and more. And so some of the lower level tasks might get redundant or are already getting redundant. But this has been always been the case, isn't so? As humanity has progressed, we have found ways to simplify various tasks. Modernization in farming, machinery has reduced a lot of manual labor work. And it has always been important for humans to develop their skills and grow with the changing world. One thing which I believe has remained common along the human growth history is the contribution of one's logical ability. If you have strong logical sense, you'll always be ahead of this changing curve. And so, in my opinion, logic is that one thing which will always remain superior to AI. Hello everyone, my name is Jitesh and I am CEO at Logical. I have more than 16 years of experience working in the software industry. As part of this video series, we'll be concentrating on solving some typical questions to build your logic. Please note that we will be software language independent while we discuss this logic building exercises. Our aim is purely to make you start thinking logically. So all right. So let's discuss our first exercise. Let's assume we have two lists. One is the master list and another is the search list. The first list has a list of names in two columns, name 1 and name 2. Let's just understand that the column in name 2 is basically an alias for name 1. So each row basically is representing one person here. So Brendan Grant is probably also known as Paula Hoffman, right? These are just examples, so do ignore the exact names here, but I'm just taking an example here. And we have another list, which is basically the search list. And what we need to do is the names in the search list, we do need to match them with the names in the master list. So if the names occur either in name 1 or name 2, that person is supposed to be labeled as found, right? And that's the exercise which we are going to discuss today. Let's take a small pause here. I would say stop, pause the video for some time and grasp the problem and try solving it at your end. Think logically as to how could you approach this problem. Once you've spent some time thinking on your side, you can resume watching the video. All right. I've assumed that you would have paused the video and that you have given it a thought. Uh, we would now proceed to solving the problem. There are a few steps which are important while solving this particular problem. Uh, One of the first step here would be to finding an algorithm which is going to help you match names between these two lists. There are multiple algorithms available in the market uh, which can be used to match names. One of this algorithm is called Levenshtein algorithm, which is what we are going to use today. And so for matching the names, what does the Levenshtein algorithm says is it mentions that what is the number of minimum letter change you need to do between two names in order to uh, create the first name to become the second name. I think it's easier being explained with a simple example. So let's say there are two people here. The first person is called Ramesh and the second person is called Mahesh, right? And as you would notice, there are two letter changes needed, one at the first position and at the third position for us to change Ramesh into Mahesh, right? And so as per Levenshtein algorithm, the number of changes required are two for Ramesh to become Mahesh. In other words, I could also say that it's 33%, there is a 33% difference between the two names, right? Or to put it yet in another words, the two names have a similarity score of 67%, right? So how close are the two names? They are around 67% close. And now this gives us a good comparison base to start comparing the names given in the two list, right? So we have a, in this our example, it's a 67% similarity score. Now let's go to the second step. So we now understand that, okay, there is an algorithm available with us which can help us match names. But to match each name in the search list with each name in the master list, we need to go through the concept of looping, right? So we would have to pick up names in the first list and match them against each names in both the columns in the second list, right? Now this is the concept of looping, using which you can run through the entire data set multiple times. For a small data set, the impact of looping is going to be hardly visible, right? And you could expect the program to just run instantaneously. But for a large data set, such activities can be highly taxing on the overall performance, right? But before we think in those directions, we have another problem which we would like to handle, right? Many times the names which are written, right? People might write their name in different orders, right? So let's say somebody named Mohit Sharma in first list could occur, or in the master list would be written as Mohit Sharma, while in the second list he could be written as Sharma Mohit, right? So this brings in the second problem which we see a lot with the two data list. And we need to be able to solve this problem. And as you would have probably already thought, the way to solve such kind of problem would be to have all possible combinations of words in the names. So let's say if I could have, let's say Mohit Sharma is basically having two words, Mohit Sharma. If I do permutations of the name, right, I would have two outputs, Mohit Sharma, Sharma Mohit. And as you can see, one of these two names do occur in the second list. And so now we are able to do a match between the two lists, right? And that does takes care of one of the problems which we had. Um, Now the second problem which is there could be because of the spelling mistake. So let's say instead of Mohit here, if somebody has written by mistake Mihit Sharma, right? And now if we are sure that, or depending on case by case, uh, we still want to find out if these two persons are close or similar. Now, so somebody might say that as to why do we even need a similarity algorithm? While we are trying to match the names, we should just do a permutation of the names and try to find the exact names between the two lists. And I would agree that would be the case depending on the use case in hand. Um, but for a use case which is not very strict, right? And when we are while we are trying to find the most probable matching names, um, one such case could be while you have a master list with multiple with names also along with their email IDs, and you have a secondary list while you are trying to match these names with the master list, and you are trying to find out the emails for this search list, right? And then you would say that, okay, even if I'm trying to run a marketing campaign, if I'm able to find out that one person who is a very close match to the names in my search list, that's good enough, right? Which is where we land to the concept of threshold. So we need to set a threshold, right, for the similarity score, which would be like to say that, okay, let's, if the similarity score is more than 80%, we are good to consider that we have found the matching name in our master list, right? And so what this similarity score threshold should be completely depends on the exact use case which we are trying to solve, right? And there is no, um, uh, I would say there is no such rule which would say that, okay, one is, it should be either 80% or 70% or 90%. It completely depends on the exact use case, uh, the list in hand, as to how has been managed or how clean it is, right? And based on that, you could decide on the exact threshold. So I would say that we should run a small dry run on a smaller set of data set to find out what would be the ideal threshold, right, to manage your entire use case. Right. With this two problems solved, I would also like to highlight one of the issue which we faced while we were trying to solve this exact problem. So as we said, the first thing where you need to do a permutation between your word letters, right? And we were able to successfully do this, but we were still having a problem that then the, the performance of our algorithm was not that great, right? And what we noticed it, unfortunately, we were doing permutation at both the ends. So we were doing a permutation in the search list as well as in the master list. If you would have realized by now, I think that was a big mistake to do, right? Because while you would have permuted one of the names, there was no need to permute the second name from them, either the master or the search list, because you would have found the similarity by just changing one side of the name. So Mohit Sharma, when it becomes Sharma Mohit, you don't need to change Sharma Mohit in the second list also to Mohit Sharma, which is what would lead to 4 checks or 4 calls to the similarity algorithm rather than just 2. And as the number of words in your name increases, this has a compounding effect, as you would have seen. Let's say, assume if there is a name which has 5 words, right? And so to find the permutation, we just need to do 5p5, which is equal to 120. And so if I am making 120 combinations in one of the list and 120 combinations in the second list, you can understand that just doing comparison with one name between the search list and the master list, I am having a crazy number of calls to the similarity algorithm. And just by solving this one problem, we reduced this big number of comparisons to just 120, right? And so it's important to go through, our initial code to find out such mistakes which logically don't look wrong. And I, I really would like to point out here that it did took us some time to figure out that this was a big mistake which we were doing. While we initially wrote the code, we happily had the permutation on both the sides, you know, but this was a big mistake. All right. After doing all this exercise, also we were still, because the list which we were looking at was quite large. We were always looking at 100K records to match with another file which had around 50K names. The time or the performance was still not uh, as good as we would have wanted, and that made us to think as to what other boundary conditions which we could place to reduce the number of comparisons which are happening currently. And what we found is the two lists which we had names going all the way up to 5 to 6 words, right? And so what was happening is that even if the search list has just 2 words, we were comparing it with something which has 5 to 6 words. And it is highly unlikely that this is going to result in a similarity score greater than the threshold which we were looking at, right? And to solve that problem, so then what we did is we restricted the comparisons between the two lists. So let's say if I'm picking up one name and it has only 2 words in the first list, I would be only comparing it with the names which are having plus or minus 1 words. So it would be compared against the words which have only 3 or 4 words in the master list. And that basically brought a big change, a further change to reduce the time the program was taking for computations, and the overall performance did really go up, right? So to get there, I would say this 3 or 4 steps did help us in having a good accuracy as well as performance. All right. So while we have discussed one approach to solve the problem, I'm sure there are plenty of other ways to solve the same. It'll be interesting to read your feedback in the comment section on how else you could have approached the problem, or what additional boundary conditions we could have placed to further improve the efficiency without compromising on the accuracy. Right. Additionally, I would request, if you wish us to discuss on any typical logical problem, then do please write your questions in the comment sections. We will be happy to pick it up in our upcoming videos. That's it for the current video. Thank you, and see you in the next.